All right, so application. Why do we factor? Why do we solve? What's important about it? So the essential question today, what is the application or the purpose to solve by factoring? What does it have to do with the end result? We're only going to get a little glimpse today because at the end, or after our quiz over how to solve these equations, we're then going to dive into why they're important. So this is our little glimpse. What is the application or the purpose to solve by factoring? So you already have this down. The table's already filled out for you. During the Chapter 5 pretest that you took on Friday, hardly anybody, actually nobody during second hour produced a T-chart. I can say that. Nobody during second hour produced a T-chart. So we can produce a T-chart plugging in numbers, trying to see what's this going to look like. But we've got to figure out how to plug these numbers in. So if I plug -2 in to the X piece, I have to say, okay, -2 in parentheses squared, -2 times -2 in parentheses, -3. And we do that for every single thing in the T-chart. I already trust our skills about evaluating because that was in Chapter 1. So let's just write the outputs for right now. After graphing them, we realize it's actually not going to produce a straight V. These are parabolic figures where there's a little curve. There's still a dip at the end, but there's a curve. Notice, this is how we're going to connect the points. Now, you do not need to memorize this, but this is where the application is starting. When we solve an equation by factoring, we actually figure out X-intercepts. So when we factor and solve by making that y-coordinate 0, we actually find the special points about y-intercepts. My bad. Bleep, bleep. X-intercepts. Now, we can't dive a whole lot into more application, but that's where we're going to be heading in part 2. We're going to have to use solving by factoring to figure out the x-intercepts. Here we go. So, 0 of a function. So it's the x values where the graph crosses the x-axis. This word zeros, can you highlight that or underline or box or star? That word 0 is going to be in directions. That word 0 is going to be in directions. It was on your pretest. Find the zeros. A lot of you are like, I had no clue what that means. So the word 0 of a function is where the x values, where the graph crosses the x-axis, also known as the x-intercepts. So to find the zeros of a function, we're going to make the y-coordinate be 0. So we're going to plug a 0 in for y and solve. So intercept form is going to be useful later on because the function is going to be written in factored form. It's called intercept form because you're going to easily find the x-intercepts with that 0 product property. Zero product rule. On your Chapter 5 test, you actually have to figure out the zeros of a function written like this, and the quickest way will be to find the zeros by factoring or writing it in intercept form. So what we're going to do is factor first, get it in intercept form, and then find the zeros by setting y or plugging a 0 in for y. So follow along with me. What we're going to do is first factor. We look for a greatest common factor first. That's our thought process. Look for the greatest common factor first. We have none. So then we look for, okay, 3 terms I'm going to use. Multiply, add. So what multiplies to -6, adds to -5 is the question. Okay. So then I'm going to write this equation using those numbers. Notice how I have y equals the quantity x plus 1 times the quantity x minus 6. This is intercept form. If we practice it now, we won't have to worry about it later. So this is not going to be in homework, but it's going to be on your test later on. All right. So we're going to use intercept form to figure out the zeros. What we do is we plug a 0 in for y. So make it 0 equals yada yada. So in the first set of parentheses, x plus 1, one of our solutions is going to be -1, the other solution is going to be 6. But we have to recognize later on the application is, those are going to be our x-intercepts, -1, 0, and 6, 0. So in this example, we're going to get it in intercept form. Let's figure out how are we going to factor that. We've got our intercept form. That's not going to be an answer in homework. It's not going to be an answer on a quiz, but we're still going to practice it in notes. We're going to use that to find the x-intercepts, to find the zeros. So we're going to set the equation equal to 0 and figure out what the x-intercepts are. Taking each factor, figuring out, well, what'll make them equal 0. Plus or minus 1, where you have a positive and negative. You could write it as that, or the previous step is okay. And again, the application is, hey, these are going to be the x-intercepts when we get to part 2. So, same process. We're going to get it in intercept form first. Intercept form first by factoring. Wait a second. We've got to figure out what multiplies to 60. We've got to take that leading coefficient, 6 times 10, to figure out what multiplies to 60, and then adds to that linear term, 19. I'm going to tell you, if you took 4 and 5 times, or 4 and 15 times each other, you get 60. But then when you add them, you get 19. But here's the thing about bottoms up. After you figure out your two numbers, you always need to divide it by the leading coefficient. The bad thing about the previous examples is the leading coefficient was always 1. Now we have a leading coefficient that's not 1. So you got to divide both numbers by 6. We need to reduce. Both of these items will reduce inside. And both is still going to have a denominator. So we're going to move that denominator to be a coefficient in each factor. We've now got it in intercept form. Now we're going to use intercept form to find the x-intercepts. We get answers of -2/3 and -5/2, which just remember that those are x-intercepts. Last one of these. The greatest common factor is a 2, but then we have to produce a multiply add. What now multiplies to 21? Adds to 10. So to practice intercept form, technically, what's up on the screen is the entire intercept form. Y equals 2 times the quantity x plus 3 times the quantity x plus 7, and so on. But now we're going to figure out, okay, what'll be the zeros? What'll be those x-intercepts, and so on. Once again, these are x-intercepts for later application. So the intercept form method is for later application, as well as these guys are for later application. I will just be asking you for the zeros. That new vocab word. All right, so let's see some sort of quadratic word problem that you will need, that factoring will be helpful for. So you've got a rectangular stained glass window, it's 2 by 4 feet. You have 7 square feet of clear glass to create a border of uniform width around the window. What should be the width of the border? Or what should the width of the border be? Anytime you get a word problem, you actually do have to read it. Sometimes we're like, what? Word them out. You got to read it. Now let's go back and actually draw something. So looking at that first sentence, let's draw it out. You've got a rectangular stained glass window. It's 2 by 4 feet. So draw a rectangle on your piece of paper and put down the numbers 2 by 4. So that uniform width around the window has to be the same width. So if I look at the width all the way around, it's going to be the same width. So whatever the width is here, it's going to be, I don't know what it is, so I'll label it X. I don't know what it is, so I'll label it X, and so on. Same width around, all the way. So now that we realize we're dealing with area, let's write up the formula. Area is going to equal length times width. And we now know that that blue rectangle is going to be 2 by 4, so that blue rectangle has an area of 8. And that 7 square feet of clear glass for this border has to be out here. All of this border put together has to have an area of 7. Out of curiosity, though, what about the total area? The area of this entire green rectangle is going to have a total of 15 combined. So we're going to have 15 equal to. The length and width are going to look a little funny, because the length is not just a 2. The length is now an X length plus a 2 plus another X. We're going to label that as 2 X's plus 2. And then with the width, it's no longer just a 4. So a 4, but wait, we have a little extra of an X, and then we have a little extra of an X. So it's like X plus the 4 plus another X. So the width is going to be like 2 X's plus the original 4. That's what we're going to use as the area. Okay, so ladies and gents, we've got to recognize I'm not going to give this to you on a test. I'm not going to give this to you on a quiz, but it is standardized test worthy. This is a problem that would separate what, I hate to say it, but there's like that common phrase where I'm from, separates the men from the boys. All right? So this sort of problem really separates the connections between the brains. Like, can your brain handle all this information? This was information overload. From here, I just want you to watch what happens, because from here it goes back to yesterday's stuff. Yesterday we would completely FOIL or double distribute. We would completely double distribute that right side, get everything on one side, and then we would factor. But in this case we would be like multiply add. What multiplies to negative 28 adds to 12. We would figure out those numbers and do bottoms up. So because we have a leading coefficient that's not a 1, we're going to divide them both by 4. Reduce and bring bottoms up, and then figure out these numbers, and so on. I just want you to see the context. We get these two numbers. Should this width be half a foot or negative 3.5 feet? Like, you do all this algebra, and then you come up with these numbers. Half a foot or 3.5 feet. What should the width be? Because we can't have negative feet, the solution would be 1/2 foot. Now, I am not going to give you this sort of problem on a test. I can let you know that this video is being recorded. If you do want the rest of these notes, you can go back through on the YouTube channel, latest updated video, and you can write all the information down. Most important part was just to see how quadratics are used with an area problem. Area problems. I want you to get this homework down.